in this other situation, we have that if Vancouver has a population of 400,000 and is growing at a rate of 2% annually, and Surrey has a population of 300,000 and is growing at a rate of 3% annually, in how many years will Surrey catch up to Vancouver in population? Like, how many years will it take for the population in Surrey to be identical to the population in Vancouver? So we're going to start by splitting all the information that we have that corresponds to Vancouver and that corresponds to Surrey. I'm going to be using P here for population. All right, so let's do Vancouver. They said that the population is growing at a rate of 2% every year. That means, so V for Vancouver, that means that the population in year 1 over the population in year 0, or the population the following year, let's say, that is going to be equal to the common ratio. And the common ratio will depend here on the 2% of increase, right? So every year, the population increases by 2%. This is similar to what I just discussed in the previous example. Look at this. If the population right now is A, and now I have a rate of increase of 2%, so plus 0.02a, then the overall effect is now 1 plus 0.02. So 1.02 times a. So then that means that the common ratio here will be 1.02. Which beautifully now is giving us the base of the exponential model that will represent Vancouver. So continuing here, I'm going to continue right here. The exponential model for Vancouver, I'm going to put a subscript V for Vancouver, at t is going to be equal to A times B to the t. We already have the base. The base is 1.02. And also A, we can get A by using the initial population, the population at time t equals 0. Look, if t is equal to 0, b to the 0 is going to be equal to 1. So A becomes the initial population, which in this case was 400,000 individuals. So the population of Vancouver at t will be 400,000 times the base 1.02 to the t. So here is the model that is representing the population for Vancouver. Now, let's go over here. We're going to go ahead and do Surrey. So now again, the population, I'm going to do the ratio of the population at 1 over the population at 0. And I know that this is going to be equal to B. And following the same analysis that we did here on the left, I know that B, the common ratio, will be in this case 1.03, because for Surrey it's a 3% increase, annual increase. So then that means that the population of Surrey, as for Surrey, at t will again be A times B to the t, which it is going to be, A is the initial value. So the initial value for Surrey was 300,000. So 300,000 times the ratio, 1.03 to the t. And here we have it. So now what we want to do is to figure out at which particular time the population of Vancouver will equal to the population of Surrey. Okay, so right here. So when will the population of Vancouver equal the population of Surrey? When will that happen? So in order to solve for t, we're going to set the two formulas, this one on the left and this one right here on the right, we're going to set them equal to each other. That means that we're going to have 400,000 times 1.02 to the t equals to 300,000 times 1.03 to the t. So that's what we have. Now what we are going to do is to start simplifying as much as possible. So I'm going to go ahead and divide both sides by 400,000. Same thing over here. This will cancel and this will simplify beautifully to 3/4. So we're going to have 1.02 to the t equals to 3/4 times 1.03 to the t. And then again, to continue simplifying, I will now divide by 1.03 to the t. Both sides will be divided by that. On the right, they'll cancel. And on the left, I can use properties of exponents to rewrite this expression as 1.02 over 1.03, all of it to the t. And that's going to be equal to 3/4. And now we're going to do the same thing that we did before. In order to bring t down, we're going to take the log of both sides. And we are going to have t times the log of 1.02 over 1.03 equals to the log of 3/4. And now we're going to divide both sides by this factor right here. So then t is going to be equal to the log of 3/4 divided by log of 1.02 over 1.03. And at this point, we're going to get our calculators and we will enter all this to get a decimal approximation. And the decimal approximation should be about 29.5 years. That means that it will take about 29.5 years for the population of Surrey to catch up all the way to the population of Vancouver, for those two populations to be equal to each other.